Hello, I am Chris Lopes, and this is the recounting of my experience using Clojure, Elixir, and .NET Core. I am a web developer, but I moonlight helping to check kids into classrooms. The system we use is pretty slick. It's, for the most part, self-service. We have limited space in our classrooms, however, so we need to set a max amount of kids for each classroom. So we have done so in the system. Unfortunately, once the maximum amount has been reached, the system is quite happy to continue to check kids into the classroom. So one of my duties is to every so often stop people from checking in, switch over to the admin screen on the computer, refresh the page, scan through the list of classrooms, and if any are getting full, go over to a whiteboard, change the status from open to full, and then let families continue to check in. Then I wait around a little bit longer. Hopefully there's a lull in check-ins, go back up to the admin, refresh the page, and hopefully I don't see this overcapacity. Some teachers are not going to have a very good day. So after experiencing this unpleasantness a few times, I started to ask some questions. And as a developer, one of the first questions I asked was, does this system have an API? And sure enough, it does. And not only that, but it also supports webhooks. So with this information, I started to plan out an application I would create. On the left-hand side, we see our standard check-in screen. And next to it now is a list of our classrooms, color-coded for easy identification, displaying the status of each class. So the plan is to create a web application that will serve this page. When it is rendered, the browser will establish a WebSocket connection back to the server. The server will also expose an endpoint for the webhook to call. When the webhook calls the endpoint, then the server will go out, use the API, retrieve the list of check-ins, calculate the new totals for the classrooms, and then broadcast that out to any connected clients. I'll have a second page I can pull up with my phone and see the counts of the classrooms as check-ins occur as well. I figured that this would be a nice, simple learning project, so I decided that I would use it to create the same application in Clojure, Elixir, and .NET Core. A little bit of information before I begin. I am a web developer on Windows at work, but at home I run Arch Linux. So I'll be using Arch as the system I do my development on. And a little heads up as well, there's quite a bit of sample code as we go. The intention, though, is not to understand the details of the code, but more give you a sense of what it's like to develop in each of these stacks. So let's begin with Clojure. Clojure is a dialect of Lisp. It is a dynamic functional language, and it is a hosted language. So there are several implementations, including one that runs on the CLR. The primary implementation, though, runs on the Java virtual machine. The other interesting implementation is ClojureScript, which compiles down to JavaScript. Cognitect is the maintainer of Clojure, and Rich Hickey, its creator, is considered its benevolent dictator for life. If you haven't worked with a list before, here's an example of the basic syntax. It consists of a list where the first item in the list is an operator, and all additional items in the list are arguments to the operator. So it's prefix notation here. If we want to, say, multiply two numbers and use that in our list, we can do so by inserting a nested list. So lists will be evaluated from the inside out. The multiplication will occur first. The result of that we return to the addition list and used in the summing of the numbers. This is the basic, simple, and consistent syntax of Clojure and of Lisp. Here are examples of the map, filter, and reduce functions. In each case, we are generating a range of numbers at first. For the map function, we are incrementing each number. For the filter, we are looking for a list of even numbers. And for the reduce function, we are summing the numbers once again. If we want to, we can combine all functions into an expression by, once again, nesting the expressions. And once again, evaluation will occur from the inside out. So start with a range and work its way in. This begins to illustrate a common concern working in Lisp languages. First, you can see that the parentheses begin to stack up on the right-hand side there, and so concerns of having to count parentheses and make sure that they match. In my use, I didn't find that to actually be much of a concern because most editors do a pretty good job of counting parentheses for you and matching them. And there are even plugins that take advantage of this simple Lisp syntax to be able to move around lists. The other concern, though, is readability, and it can be challenging to read the syntax from the inside out. As a solution to that, there are threading macros, as seen on the bottom example here. We're using a threading macro which will take the result of the previous expression and supply that as the last argument to the next expression. So here, the range of numbers will be evaluated first, and that will be supplied as the last value to the map function, and et cetera through the remaining functions. So this allows you to read the code in a more normal and traditional top-down. Lineagain is a tool in Clojure to manage Clojure projects. It does not come with Clojure, but this is a tool that the community has built. There are other tools that you can also use, but Lineagain is the most widely used one. With it, you can do the typical task of creating new projects, running builds, managing dependencies, running tests, starting a REPL, etc. It's also extensible, so you're able to add additional functionality that you like. For web frameworks, Clojure does not have a complete out-of-the-box web framework. Instead, typically you will see Ring being used, which is a Rack-inspired web framework from the Ruby world. And then people combine that with other libraries. A common library is Composure to help in specifying your routes. Part of the community has identified this as being an issue, though. And so recently there was a Kickstarter campaign that was funded to create a complete out-of-the-box web framework that will be approachable for beginners, as well as pluggable and customizable for advanced users as well. The other side of Clojure is ClojureScript. In ClojureScript, you have client-side web frameworks, the most popular of which wrap React from the JavaScript world. Reagent is one such framework. With Reagent, you're able to create React components in ClojureScript. Reagent also comes with a Lineagain template, so you're able to scaffold out a project easily, and it also includes the server-side bits using Ring and Composure. So I found that this was the best way to get started with a project, so this is how I began. So we'll begin with installation. I'm using Arch Linux, remember, and Pacman is the package manager in Arch Linux. So the first thing we do is install Clojure from the community repo. Next, we need to install Lineagain. It's in the Arch user repository, and so we'll use Yaourt, a package manager in the Arch user repository. Once we have that in place, we can go ahead and create our new Reagent project. Once it has been created, we can take a look at what was generated. Specifically looking in the source directory, we see three directories that were created. We have a CLJS directory for our ClojureScript code. We have a CLJ directory for our server-side Clojure code. And in the middle, we have a CLJC directory, which you're able to share Clojure and ClojureScript code. The first thing we'll do is set up our routes. If most interest here is our post route for our new check-ins, that will be the route we expose for the webhook to call. When the webhook calls our endpoint, we need to retrieve the check-ins from the server, from the API. The check-ins are returned 20 at a time, so we'll need to page through the list of check-ins. So the way we do so here is we have a let expression. The let expression will scope variables to just that expression. So first we create a variable for today because we only want check-ins for today. Then we have another variable that will store the results of the check-ins for the current page number. Next, we have a variable that will consist of the previous check-ins as well as the new check-ins that were retrieved. We'll then compare counts. If the counts are the same, then we don't have any new check-ins and we'll return. Otherwise, there could potentially be more check-ins on the next page, and so we'll use recursion, increment the page number, and call the function again. The API requires an HMAC signature, and Clojure does not have a library to generate such a signature, but it is fairly easy to use Java library and Java interop to create the signature for us. In Clojure script, we need to create a component to display the contents of our classrooms. So here we are iterating through the list of classes, and for each list we have a list item. For each list item, we have a div element where we use inline styling to style the background color of the div item to the color of the classroom. Then for the contents of the div, we are outputting the name of the class as well as the count and the maximum number for the class. Another nice tool when working with Clojure script is Figwheel. Figwheel provides several benefits. The one I'll talk about here is it hooks up a browser REPL for you. So this allows you to interact with the browser as well as your Clojure script code that is running in the browser. So in the first example, we are sending an alert dialog that the browser will show. In our second example, we are changing into the namespace of our Clojure script code. Then we have our classrooms list, and we will map over it, changing the count of the classrooms to 2 for all classrooms and store that in a variable. Then we'll swap in those new values into the list that that Clojure script is using. And so when that new classroom value is swapped in, all affected components will update with a classroom count of 2. Reagent comes with a proc file for deploying to Heroku. There are other ways you can deploy Clojure code, of course, but this was the most straightforward way for me. It had some minimal instructions to get up and going, but it was enough to be able to deploy my code. After spending time in Clojure, I found that the community was very passionate and very enthusiastic about what they're doing and the things that they are creating. They're very active in creating numerous tools and libraries. I found using the REPL in Clojure was very helpful as I was experimenting and learning and trying to piece together my application. Also found that using Clojure script was very refreshing, not having to set up a JavaScript build and all the tooling and making all those decisions. I did struggle a little bit with not a complete out-of-the-box web framework once I had to get off the base path that's provided. I struggled a little bit. I also found that working with Clojure, often the code can be terse. I have a little sample here. It's out of context, so it's even more difficult to read. But just to sort of illustrate, first we have cons, the cons function, which is a traditional name, but it makes me stop and think, really, why are we still using this name? And not the most descriptive, but is well known. And then X, so we like our single letter variables here, as well as F and S. So in context, you're able to determine what these mean, but it can be terse. And so as I was working with Clojure, I found this tweet by Gary Bernhardt to resonate with me. Another issue I found with Clojure is the errors that are produced. So as you can see, it was difficult to fit this stack trace on the screen. It is very verbose, and unfortunately is unhelpfully verbose. So in this particular error, there actually was no reference to what actually was causing the problem. So moving on to Elixir. Elixir is also a dynamic functional language. It extends and was built upon Erlang. So it runs on the Erlang virtual machine, or affectionately known as Beam. A core principle of Elixir and the programming is the use of processes extensively in your program. These are not operating system processes or threads, but are very lightweight, in which you can have tens of thousands of these running simultaneously. This is what allows you to be able to create a distributed application in Elixir and be able to scale horizontally. Jose Valim of Platformatech is the creator of Elixir. Another key principle in Elixir is pattern matching. In this first example, we see that we're assigning the string hello to the variable a, which makes sense. But the next line is a little more curious. We're taking the variable a and assigning it to the string hello. It seems to be OK with that. So we'll try a different string. We'll assign a to the string world, and that it complains about. So what's going on here is the equal sign is not an assignment operator, it is a match operator. It's trying to match the left-hand side to the right-hand side. So in the first example, when there is a variable on the left-hand side, it will bind the value on the right-hand side to the variable on the left-hand side. Here are examples of the map filter and reduce in Elixir. As you can see, we're starting with a range of numbers. The backslash here is just a line continuation character working in the interactive environment. But then you can see as well that Elixir borrows the pipe operator from F#, and it will pipe the result of the previous function as the first argument to the next function. So here the range of numbers will be provided as the first value to the map function, and then the result of that, the first value to the filter, and the result of that, the first value to the reduce. Like I said, processes are a key concept in Elixir. There is a set of libraries called OTP to help managing of the processes. Agent is one such library, part of OTP. It is an abstraction for storing state. So in Elixir, you store state inside a process. So in this example, we are using agent to first start a process, and we initialize the state to an empty list. When the process is created, it will return a tuple with a symbol of OK in the as the first item. And as a second item, it will return the process ID of the process that was created. When we want to update the process or update the state, we'll use the update function. And we need to supply the process of the ID, need to supply the process ID of the process we are updating, and then the function to update the state. In this case, we are appending hello world to our list. When we want to get the state, we can use the get function, and once again, supply the process ID and the function to get the state. In this case, we are just returning the list. Then once we are done, we can stop the process. Mix is the tool to manage Elixir projects. It comes with Elixir, and you can do the typical things of creating projects, running builds, managing your dependencies, running tests, etc. Phoenix is the most widely used web framework in Elixir. It was designed to be familiar to those coming from other web frameworks. It has an MVC type structure. It comes with its own database framework, which is pluggable, called Ecto. And it also comes with a JavaScript build set up and configured through Brunch. It has an unfortunate naming, and I hope that it doesn't come to the fate that Jemmy states. So let's begin with our Elixir project using Phoenix. The first thing we will do, start over here. Okay, so the first thing we'll do is we'll use pacman once again to install Elixir. Once we have Elixir, we next need to install the package manager Hex. Once we have Hex, we can go ahead and install Phoenix to generate our new project. We also need to install Node.js and npm, since that's what Phoenix uses in the Brunch configuration. Once we have that in place, we can go ahead and create our new Phoenix project. It will create a variety of artifacts for us, and we can take a look at what is generated here. We'll focus in taking a look at the web directory. And in the web directory, we will see that it created controllers, templates, views. We have routes. We have some JavaScript in there, all sorts of different things. We'll start out with creating our routes again. In Elixir, we have the concept of pipelines. And pipelines consist of a series of plugs. Plugs are composable web components in Elixir, which allow you to manipulate requests coming into your application before they reach your controllers. So here we are setting up two pipelines, one for requests coming in through the browser, and another one that will be coming through our API. When we want to use the pipelines, we can set up a series of scopes. We'll have one scope that will handle our browser requests, and then on the bottom, we'll have a different scope for our API, which the webhook will call. When the webhook calls our API, we once again will need to page through the list of check-ins. So we first start out by retrieving check-ins for the current page. Then we filter them down to just today. Once we have that list, we check to see if we actually have anything new. If we don't, we just return what we have. If we did get something new, then we will take a look at the last item in the list, and if we have that in our store already, or if we don't have that in our store already, then there could be more check-ins on the next page. So we'll use recursion once again to call into the function incrementing the page number. Otherwise, we've retrieved all the check-ins and we'll create the new check-in list. Elixir also does not have a library for generating HMAC signatures that the API requires. So we will use Erlang interop here to call into Erlang and create the signature for us. Phoenix comes with this concept called channels. Channels are similar to SignalR, where it will use WebSockets, and if WebSockets is not available, it will fall back to use long polling. You also can see here we can use the ES 2015 syntax and features because part of the branch configuration uses Babel to transpile our code to ES5. So here we can import the Phoenix module. Once we have that, we can establish a connection, register an event handler, and when we receive a message, we can iterate through the list of classrooms and change their status to either open or full. Phoenix also comes with some comprehensive instructions for deploying to Heroku. So that was the location that I chose to deploy to again. It was very helpful and started from creating an account to using a build pack specifically for Phoenix to setting environment variables to enforcing HTTPS. It was quite helpful to walk through. From my time in Elixir, I found that Phoenix fit my use case very nicely. Every time I needed to take the next step in the application, I only needed to consult usually the Elixir or Phoenix documentation or guides and was able to find the information I needed. The community is smaller, and with its unfortunate naming of Phoenix and Elixir, things can be a little bit challenging to find. But the community is gaining a lot of momentum and is growing very quickly. Some concerns I had, though, is that Phoenix and the way it abstracts how you use Elixir, I noticed after I created the application where I talked about processes are being a key principle to Elixir, that I did not use any processes in my application. And in fact, the one opportunity I did to store my list of check-ins as state, I did not do so, but I fell back to what I knew and was comfortable with and looked for a library that provided an application cache. And so just used an application cache in a library in the application instead. So on to .NET. I will skip the introduction to .NET and the language and move directly to installation. Or maybe not, because there isn't a package for Arch Linux. Thankfully, the Arch Linux community is quite active, and someone has gone ahead and created a package for me already. So let's go ahead and install this. The first thing we need to do is download the package data from the Arch user repository. Once we have that, we can unarchive it, and then we can go ahead and make the package. When we make the package, it will need to download a few different components, the runtime, and then the libraries, and then after that, it will need to download all the tooling. Once it has all that, we will need to actually compile the project and build it. Once we have done that, we can go ahead and install. Once we've installed .NET, we can install Node.js and NPM, which ASP.NET MVC uses, and then install the components Gulp and Bower, which the framework uses. Once we have those in place, we can go ahead and create our application using the .NET command line, specifying the project type of web. This will generate a basic ASP.NET MVC application for us. The routing is pretty familiar to those who have used ASP.NET MVC before. Default MVC routing, and for the web API, we will use the web API attribute routing. When we retrieve check-ins, we will need to page through them once again. And in this example, though, we are using a loop to iterate through the pages until we have retrieved all check-ins. And in the bottom function, instead of creating a new list, we are sort of merging the new check-ins onto the list that we already have, changing the state of the dictionary. One thing I found that was very helpful, and Cassandra mentioned yesterday, is a feature called the Secret Manager in .NET. One thing I didn't mention in the other stacks was the API also requires a secret key and a user token. And with the Secret Manager, I'm able to store these pieces of information outside of my application and not be concerned that I will accidentally commit that up into my repo. To use these pieces of information, we will just use dependency injection. So we'll set up our object, and then we can inject it into whatever class needs it. Right now, ASP.NET Core does not have a WebSockets library that I'm aware of. Signal R is being created right now. But there is middleware for using WebSockets. So we're able to create a minimal setup on the server side, and then on client, we can once again establish a WebSocket connection, register an event handler, and when we receive a message, iterate through the list of classes and update their status. With .NET Core, the default place to deploy your application is Azure. I hadn't used Azure before, but the documentation that's provided is pretty helpful, although geared mainly toward people using Visual Studio. It was enough to be able to figure out and configure deployment so I could once again just push my code up to Azure and have my application redeployed. After spending time in .NET Core, I found things are progressing quickly, obviously. When I started this application a few weeks ago, I had to use Ubuntu 14.04 because there wasn't packages anywhere else that I could use. But then a couple of days before it went final, .NET went final, there was a package for Ubuntu 16.04, so I moved to that. And then a couple days after final, there was a package in the Arch user repository, so then I was able to move to that. So things are changing, and that has an impact on other things like the documentation. The documentation was helpful, and it described a lot of what I needed to do, but some of it is now out of date and still referencing things from RC1. Like I said, the Secret Manager was a nice feature that I enjoyed using. And there are other missing pieces that are still being built out. Like I mentioned, Signal R not being available. And then when I used the .NET command line, the only project type I could specify was just a web project, and I didn't have any control of any other web project that could be generated from it at this time. I use Visual Studio Code, but I had some issues using Visual Studio Code as well. I had issues with starting OmniSharp, didn't seem to want to recognize and give me the IntelliSense, as well as when Visual Studio Code starts up, it tries to initialize a debugger, and it was not able to do that as well. So here's a comparison of the different stacks, and as you can see, there are several components, or they all have similar components. The last item in the list, though, I'd like to spend just a moment and talk about. Both Cognitech and Platformatech are consulting companies, so their primary business is client work. So when there is a gap in the ecosystem, the community doesn't necessarily go out and look to them to fill that gap because they may not have the ability to have the resources to address those issues. And so there's more onus and freedom in the community to build out these tools and libraries themselves. Compare that to the .NET community with Microsoft. There's more of a mindset that Microsoft has teams dedicated to the language and to the framework and to the tooling. And so there's this mindset that Microsoft will fill those needs. And as Don stated yesterday, that can be a challenge, that can be an issue. And so as I was thinking about this, and as I spent time in each of these stacks, I realized that all communities have their challenges. So this is not unique. In Clojure, recently there was an article written expressing concern about the direction of Clojure and some of the decisions that the core team is making, to which Rich Hickey replied in perhaps not the most helpful of ways. Elixir also, being a young community, is having their own challenges as well. They recognize that Phoenix is doing a great job bringing people into the ecosystem, but the way that Phoenix abstracts so much of what's going on in Elixir, people are able to just bring in what they know from other frameworks and try to apply that to Elixir instead of learning the Elixir way of doing things, which is sort of what happened to me. So there is concerns that as community grows, and especially as it's growing quickly, these bad practices will propagate throughout the system. So I'm thinking about the .NET community, and I'm thinking that right now we're at a rare time. We're at sort of a unique time because things are changing. There's an opportunity to shift mindsets. So I really appreciated Don's comments yesterday and James talking about the community this morning as well. The problem that I have when I hear that is when I hear those call of actions, for some reason I don't include myself as being part of the solution of wanting to take action. I consider the people that are going to do this and make the shift are the people that are already active in the community, the people that are running user groups, the people that are creating conferences like this, and not me. But I was thinking again that this is a community. It is a community, and I am part of this community. And so I have a role in this community. Now, I can't do everything, but there is something that I can do. So what does that mean for me? What are the implications for me? And so I ask that for you as well. What are the implications for you? You are part of this community. If you'd like to discuss any of these things, have any questions, share ideas or thoughts, I would like to hear them. Come find me. I'll be around. Thanks.